Hello friends, welcome to this lecture of algorithm design. In this introductory lecture, we are going to discuss why we basically do study of algorithm design in computer science and how we can make the study of algorithm design easy and fun to study. So, what is algorithm? Let us first discuss that. See, in computer science, especially in computer programming section, we are provided some problem whose program has to be designed. So the program can't be developed in a one go. There are certain stages that we have to follow while defining a problem, and you can say the tool which is basically used to define the problem in a systematic manner is algorithm. Fine. So what actually the algorithm is? An algorithm is step by step set of unambiguous instructions to solve a given problem. So when we talk about algorithm, what we actually mean that as a programmer we are supposed to define a set of unambiguous instructions to solve a given problem. And what is the idea of unambiguous instructions? It simply means that when we define the instruction, we must make sure that it must not lead us to some confusion or some, you can say, it cannot alter the meaning of the problem. Fine. We have to define the problem in such a way that we are able to define the exact solution for the given problem. That is the idea of unambiguous instruction. So how we can do that? Let us check that. In a computer in computers, basically we are provided with some problem and with some input of size n, and what we are supposed to find the solution as some output of size n. So what actually the idea of using the algorithm is so it is very clear, the idea of algorithm is to find out the solution of the given problem. Fine. So algorithm is basically the mapping of the problem to its equivalent solution. Fine. And this can be understood in this way that suppose we have to sort an integers. Suppose there is a problem. This is basically the problem that we are provided in a computer language, that we have to sort an integers, and in order to sort this an integers, we can make use of various sorting techniques as an algorithm. which includes bubble sort, selection sort, insertion sort, merge sort, quick sort, shell sort, radix sort, bucket sort, count sort. To find out this solution in the form of sorted and integers. So that is the fundamental idea of the algorithm. We have a set of algorithms to find out the sorted and integers for a provided problem of an integers. So now the question is, out of these algorithms, which algorithm would be the best to find out the solution? So this depends upon certain parameters. Let us check that. What are those parameters? So suppose there is a problem and we have assigned this problem to suppose 3 persons. Person 1, person 2, person 3, and each person is required to define the problem and define certain algorithm for that problem. Now the idea is which person has defined the best algorithm to solve a problem. Now how we can say that the algorithm is best? Fine. So there can be some parameters in terms of on the basis of which we can define a problem to be good or bad. And what are those? In computer science, we basically use 2 parameters, and these parameters are space and time. So the space as a parameter basically discuss that how much memory would be consumed by the program defined for a given problem, given algorithm in main memory of the computer. Fine. And the time as a parameter basically defines that how much time would be required for a given program that has been obtained from the algorithm to solve a particular problem on the system. So with respect to these parameters, we define whether an algorithm is best or worst. Fine. So in entire discussion of the algorithm design, we have to discuss 3 things. First, we have to define the problem with the help of algorithm, and after writing the algorithm, we have to analyze that what would be the time taken by the algorithm to solve a particular problem. See, one thing is clear, that in today's scenario, space is not the major issue in computer science, because we have come from the far generation where we don't have to rely much on the much on the requirement of the space. See, there was a time that when we make use of lots of techniques like there was a floppy disk in past to store the information, and the floppy disk used to provide the limited space. Then we move to the next phase of the you can say computer development, where we move from the floppy disk to the CD-ROM, which provide much more space than the floppy disk. Then we move further to the you can say the hard disk, or other you can say secondary devices, which provides us you can say a large amount of the memory space there. Now today we don't have the problem of the memory, we don't have the problem of storing the information, because now we have the devices which can store the things in terabytes, fine. But once it was very difficult, because we had only the devices that could store the information in limited amounts, suppose in MB or KB. But today we can store the information in terabytes, fine. So that is not the problem in today's scenario. The problem or you can say the challenge for the programmer in a computer industry is always the time, that how we can define the problem to solve a particular problem in a smallest possible time frame, fine. So the issue of the time was the challenge in the past, it is a challenge in the present, and it will always be challenge for the computer programmer, fine. So in entire algorithm analysis, we have to define a problem in terms of the time. So we would determine the various time complexities to define a given problem's efficiency, that how efficient a particular algorithm for a given problem is. So in this journey of the study of algorithm design subject, we have the contents that we have to study here is, first we have to make study of asymptotic notation, and with the help of asymptotic notation we would be able to define the time complexity, that how much time is going to taken by a given algorithm to solve a given problem on the system, fine. So we will discuss the time complexity, and it is a very important topic, because you can say it lays the foundation for the study of the algorithm design, fine. Second thing is recurrence relation. We have to discuss about recurrence relation. Then we will move to the topic of recursion, fine. That is the three main topic that we have to discuss, and these are you can say these are the basic techniques to represent the complexity of the problem, fine. Now thereafter we will move to the certain algorithms that we have to design, that is divide, conquer, and combine techniques, divide, conquer and combine approach to define a problem, then greedy algorithm, then dynamic algorithm, backtrack algorithm, branch and bound algorithm. And finally we have to discuss about NP, completeness problem, P and NP, class of problems. So this is the reason that and you can say the content that we have to cover under the algorithm design subject in computer science. Now the idea is how we can make the study of the algorithm design easier and funful. So the simple idea is that what you have to do, you have to go through the entire lecture series carefully. Fine. You have to carry a register with yourself, and you have to point out all the important things that are going to be discussed in the lecture. And finally, you have to make the consistent revision. You simply choose a day to study the algorithm design and just spend a limited time to study each and every part of a discussed topics in the algorithm design. So this is all about from this lecture.